Hello dear friends, welcome to class 8 chemistry. Myself Zainab Bahari. I welcome you all in the second semester of our this academic year. Dear friends, in this term we are going to complete chapter number 6 part B. This part is in the second semester. First part already we completed in the first semester. 6th chapter B part is nothing but about types of chemical reactions. We will study with experiments in the detail each of the type with so many examples. Chapter number 7 is hydrogen gas. Here we are going to study about the element hydrogen, its properties, both chemical property and physical properties, with preparation in the large scale, in the small scale, and different reactivity of hydrogen. The next chapter, chapter number 8, water. In this chapter also, we are going to discuss the detailed study of water and different properties related to water. And the last chapter, that is chapter number 9, is carbon and its compounds. Here we are going to study about the detailed carbon, its allotropes and its different compounds and their physical as well as chemical properties. And also we will go for comparative study of all allotropes. Remember, chapter number 6 B part and chapter number 7 will be included in the second unit, while the remaining two chapters will be considered in the second semester. So, for the part second unit, we will study chapter 6 B part, types of chemical reactions, and chapter 7 hydrogen. So, let us begin chapter number 6 B, types of chemical reactions. So, dear friends, basically chemical reactions are divided in the 4 types. Namely, they are combination reaction, second is decomposition reactions, third displacement reaction, and the fourth double displacement reactions. Today we will study the first 2 types in details with so many examples and 2 experiments. So dear friends, first type is combination reactions. The name combination may explain you what it is. So dear friends, combination reaction means 2 or more than 2 substances when reacts together, and the chemical reaction between these 2 substances or more than 2 substances gives a single product. Then the reaction is said to be a combination reaction. Here let us take in the general. Substance A, when combines with the another substance B, as a result of chemical reaction between the substance A and B, the new single product AB is formed. A reacts with B to give product AB. It is nothing but combination reaction. Dear students, combination reaction is further categorized as 3 types. First, synthesis reaction. Now, the name synthesis means to generate, to form new substance, to synthesize new substance. So here, obviously, you can see when one element combines with the another element and gives the new substance, new compound, then the reaction is said to be synthesis reaction. For example, magnesium, which is a metal, when combines with oxygen, it gives magnesium oxide. So here you can say solid magnesium wire when burns in the air, that is, it reacts with oxygen and it gives magnesium oxide. Along with this, the dazzling white bright light is produced. Let us observe an experiment showing this reaction. Take a magnesium ribbon and hold it with a pair of tongs and heat it in the air. It will cause burning of magnesium ribbon. Magnesium will react with oxygen from air and magnesium oxide we will obtain as a product by the combination of both magnesium and oxygen. Just observe how magnesium burns with a dazzling white light. And it produces white powder, which is magnesium oxide. Let us continue with the few more examples. When iron, which is the metal, the small tiny iron filings are burnt and allowed to react with sulfur, which is yellow colored amorphous powder. It gives iron sulphide. In the last semester, in the last topic, we have seen this reaction. It is nothing but the example of synthesis of iron sulphide. This is nothing but the combination reaction. Carbon, when reacts with oxygen, it gives carbon dioxide. Hydrogen, when reacts with oxygen, it gives water. So all these are examples of synthesis reaction, which are nothing but combination reactions. Let us look the second type of reaction. Here, in the second type of combination reaction, you can observe when a compound reacts with an element, the single product is formed. And this type of reactions are also nothing but combination reactions. For example, when carbon monoxide burns in air, it reacts with oxygen and gives the product carbon dioxide. While in the third type of combination reaction, when the two simpler compounds reacts chemically to give the single complex compound. For example, ammonia, which is in the gaseous form, when reacts with hydrochloric acid, which is also in the gaseous form, gives ammonium chloride. This is nothing but the combination reaction. Let us observe an experiment to demonstrate this reaction. Take a white glass tube. Fix a cotton soaked in hydrochloric acid at the one end of the tube. Close the tube with the rubber stopper. And the another end, soak the cotton in ammonia solution. Close this end also with the rubber stopper. After few minutes, you will observe a white ring in the test tube will
appear to form, which is nothing but the product ammonium chloride formed due to the combination of ammonia and hydrogen chloride gases. Note that the ring is nearer to the cotton soaked in acid. Reason behind this is ammonia moves faster than hydrogen chloride.
I hope you understood the detailed combination reaction concept. Let us observe some more examples of combination reactions. Note them down and learn them well with their balanced chemical equations. Phosphorus trichloride combines with chlorine and gives phosphorus pentachloride. PCl3 plus Cl2 gives PCl5. Second, sulfur dioxide reacts with water and gives sulfurous acid. SO2 plus H2O gives H2SO3. Third reaction, nitrogen pentoxide reacts with water to give nitric acid. N2O5 plus H2O gives HNO3. Calcium oxide reacts with water to give calcium hydroxide. CaO plus H2O gives CaOH twice. Dear friends, now let us discuss decomposition reaction. Decomposition you might have learned in biology. What happens? Right, it is exactly opposite to that of combination. That is, the complex substances when are broken down into the simpler substances. That is nothing but decomposition reaction. Here, if you will take the substance AB and you will break it down chemically, then it will give the two products A and B, which is showing decomposition reaction. Let us study in the detail. A chemical reaction in which a complex compound is break down on applying heat into the simpler compounds, which are 2 or more than 2, is decomposition reaction. Due to decomposition reaction, we can see the complex compound breaks up into the 2 or more than 2 elements. For example, mercuric oxide, when it is heated, it breaks down into mercury and oxygen. 2HGO gives 2Hg and O2. Here, mercuric oxide is the solid and gives mercury solid and oxygen gas. Next example, when water is decomposed electrolytically, it gives hydrogen and oxygen. Water is liquid and it gives hydrogen and oxygen gases. Here in this both decomposition reactions, you can observe the first reaction is taking place due to heat and the second reaction is electrically degraded. So first reaction is called as thermal decomposition reaction and the second reaction is called as electrolytic decomposition reactions. Here are few more decomposition reactions given to you to study. Note them down and study well.
Few more examples of decomposition reaction. A compound can break up to form 2 or more new simpler compounds. For example, a compound calcium carbonate decomposes on strong heating to form two compounds calcium oxide and carbon dioxide. A compound can break up to form both elements and compounds. For example, a compound potassium nitrate decomposes on heating to produce a compound potassium nitrite and an element oxygen. 2KNO3, when is heated, it gives 2KNO2 and oxygen gas. A compound can break up to form two or more elements by passing electric current. When electric current is passed through acidulated water, the water decomposes into hydrogen and oxygen. This is called as electrolytic decomposition of water. 2H2O gives 2H2 and O2. Oxygen is collected to anode and hydrogen is collected to cathode. Formation of hydrogen gas can be checked by burning the flame at the mouth of tube. Popping sound can be heard. Here is demonstration of thermal decomposition of lead nitrate. We need spirit lamp, lead nitrate powder, test tube, tongue and spatula. Take some lead nitrate, which is a white solid, in a hard glass test tube and heat it for some time. You will observe that a reddish brown gas is evolved which turns moist blue litmus paper into red. Also, a gas is evolved in which a glowing splinter burns into flame when heating is stopped. A pale yellow solid is left behind. The pale yellow solid is lead monoxide. The reddish brown gas is nitrogen dioxide, which is produced along with colorless oxygen gas.
We will meet in the next period with the remaining two types of reactions. Till then, keep on learning, study all the chemical reactions, their types and their examples with balanced chemical equations. Here is homework for you.